question 1A and B. So the given situation is a ball is released from rest on a smooth ramp. So for the first question, question 1A, A asks us to sketch the free body diagram. So this is the free body diagram. On our question, we use a basketball with a mass of 800 grams. So after we sketch the free body diagram, we need to find the average of x0, y0 and theta from 3 different angles. First of all, we find the average of x0. For the first angle, the x0 is 0. For the second angle, the x0 is also 0, and the third angle, the x0 also 0. And after that, we plus all the 3 and divided by 3, and we get the average of x0 is 0. After that, we find the average of y0. The first angle, the second and the third angle of y0 is also 0. So we just simply add the 3 of this and divided by 3, and we get 0. After that, we will find the average of the theta. For the first angle, we use 21.52 degree. For the second angle, we use the 31.67 degree, and the third angle we use 40.11 degree. And we add all of the 3 and divide it by 3 to gain the average of the theta. So here we get 31.1. Okay. For the second part, we have to calculate the speed of the object just before it leaves at P. So first of all, we apply the conversion of momentum equation, which is 1/2 times by mass times by v square equal to mass, gravity and height. So we already gained the data and can substitute through the formula. Then, as our ball is 0.8 kg, so we just simply substitute its mass. So the BB is actually what we want to find. So the height, how we get the height of 2.5 is actually where we take the height of 3.5 minus by 1 meter at AY. So we just simply compute this. We move the power of 2 to the other side and become square root of 2. When you compute the square root of 4.905, and we will get the speed of the object. 2.9 215 meter per second.
Hi, today I am going to explain about question C, which is calculate the distance from the wall at the ramp at B to where the object strikes the ground. As you can see from the diagram, the motion of the ball is from A, and when it reaches B, there is a dead end, therefore it will strike the ground. The distance is calculated using the x component. So first, we have to calculate what is the x component. The x component we get through xc equals to v b x. Mistake. It's xb plus vbx times tb. vbx times tb. As you can see, xb is 0 because there is no motion here. Therefore, it will be 0 plus vbx. vb we already get from the initial question, which is 2.215. 0.215 tb. We have to find tb using y component. So, for y component, the formula is yc equals to yb plus yb yt yby times t minus 1/2 gtb squared. gtb squared. Yeah. The velocity at yb is also at b. The distance traveled at b is also 0. So therefore, this one is 0. Plus this one is also 0 because yb is equal to 0. Minus 1/2. G is gravity, so therefore it will be 9.81 times tb squared. From the question, it is stated that if y0 is 0, then yc equals to 1. So we take yc equals to 1 equals to 1/2 9.81 tb squared. Therefore, we will get from the equation we will get negative 1/4.905 equals to tb squared. From this equation we will get tb is equals to square root of 1/4.905. Okay. Finally, we will get that tb equals to 0.4515. After we get tb, we insert it at x component. Therefore, equals to 0 plus 2.215 times 0.4515. 4515. Therefore, finally, we will get an equation which means x equals to 1. For question B, the question is compute the speed at which the object hits the ground. After the ball launches itself from B, we will have to calculate where it reaches the ground and at what speed. So, to calculate the speed of the ball when it hits the ground, we have to use the principal work of energy, and the formula is TA plus summation of U 1 minus 3 equals to TC. When we derive the formula, we will get 1/2 MVA squared plus VC squared equals to 1/2 MVC squared. Therefore, we will solve the question using this formula. So, the mass of the ball is 800 grams. Therefore, we will use as 0.8 kilograms. So, we fill in the data, which is 0.8. VA is 0. Therefore, we will put in 0 here. Plus VC, we can derive it as mgh equals to 1 over 2. The mass is the same, 0.8 VC squared. VC squared is an unknown, so we can derive it. So from the front, this will equal to 0, so we will just solve for the mgh. The mass is 0.8. The gravity is 9.81. And the height for this is 3.5 meters. Equals to 1 over 2 times 0.8 VC squared. After solving for both sides, we will get that VC squared is equals to 68.67. So to get VC, we have to square root the answer. And finally, we will get VC as 8. We will get as 8.287 meter per second.
Ya, Assalamualaikum warahmatullahi wabarakatuh. For my slot, I will explain about the question number 2. Okay, we go to the A first. This question is actually to calculate the velocity of the object just after it rebounds from the ground. So we can see at this point it rebounds after the object is going down. Okay. The first step, we should write down the equation first to find the value that unknown. So the equation is called a vertical motion equation. So I will write down the equation first. Okay, this is the equation to find the velocity. Okay, from this equation, we know that the SCY actually is from this point SCY, and the S1Y from this point at the key point. So we actually know that SCY is 0 minus 1 because S1Y is the final value. The SCY is the initial value. We know that also that is to multiply a acceleration. Acceleration is set by gravity. The value is negative 9.81. Why the value is negative 9.81? Because of when we can see the axis, y and x, when the object is going down, so it will be negative at this point. So that's why the acceleration is go to for negative. And then this one v1y is 0. So I will solve this question. To solve this equation, actually use the simple mathematics step that divided, multiply, and transfer the value. At this BCY is negative, and then we transfer it to the right, and the value it will be negative. So if you can see the object is going, the rebound is actually going down, so it should be a positive. I will write down the arrow. So 4.4 V0 turn per second, and I will over this to the arrow. Okay, the next step for the question A, we in the question already give the E value. The E value is stand for coefficient of restitution. The value is 0.7, and I will write down the equation first. E equal to V ground minus VCY into divided VCY minus V. As we know that the recurrent is actually 0, plus minus, so we just conclude as that, and then we put the value of VCY, VCY2 and VCY1. So we replace E for 0.7. This equation, the second equation, we want to find the VCY upon 2, because the first equation we just found that the value of VCY. So I will solve this equation using alternative step. So this is the answer for VCY2. Okay, for the question number 2B, actually asking for compute the maximum height to which the object rises after the first houses. This question asks for the height at the second rebound. Okay, first of all, we should write down the equation first. The equation is T minus M V1x equal to M multiply VAX, and then we know that VAX is equal to 2.215 meter per second, and then we put it into the equation. Should be V2y squared equal to VAY squared plus 2 acceleration bracket multiply S2y minus SAY. Okay, we know that the value of S2y is actually the height h, the unknown. Then SAY is 0. 2 acceleration. 2 multiply acceleration. Acceleration we know before this, for the question number 2A, we know that the acceleration is negative 9.81. Seems like a gravity value. And then VAY equal to 3.101 square. So we calculate this using the mathematical steps, and then we find the answer for that is equal to 0.5 meter. That's all for me. Thank you.